We at 1,500 in puzzles now? Wait, what? What the hell? You fixed the puzzle system? That's crazy. Oh, fun. Purpose. Now it's time to go back to work. We do binary search. Okay. It's a pretty like fun problem, I guess. I don't remember how to solve this really. Hopefully, see how long it takes us. Poco loves eating bananas. They're in piles of bananas. I pile has piles of bananas. Parts of quark. Come back in 8 hours. Poco can decide to eat. Can decide her bananas per hour eating rate of K. For each hour, she chooses some pile of bananas that eats K bananas from that pile. If the pile has less than K bananas, she eats all of them. And will not eat another pile during the hour. Coco likes to eat slowly, but still wants to finish all the bananas regardless of back. Return the minimum range K, such that she can eat all the bananas in 8 hours. Okay. What do we know from this problem? We know that. I mean, that's like too big. Like 170. Like there's nothing in between 175 and 150. Like, are you joking? Like, bruh. Like, that's kind of ridiculous, to be honest. But well. So if you want to find the slowest bananas per hour you can eat, you still eat all the bananas when guards come back. Okay. We know that what we know is that the max bananas she can eat is equal to max of piles. And the min is equal to. Wait, I'm an idiot. If we do the min, we fucking do it. The min's. I was just saying min is 1. Because there has to be numbers in there. Let's say 1. So between 1 and max of piles is what she can eat. Okay. Okay. What are we gonna do with H? So in this example here, let's look at like ScallyDraw. Browser storage quota exceeded. How do I fix that? Is there like a clear cache button or something? Like clear. Why am I even typing this? Clear. Like cache. Or like clear something. I don't know. I'm a little. I have no clue. What do I have to clear for that, like... I don't know. Browser storage quota exceeded? Oh, one second, I have to pause this. Yo, gang. There's no way just to delete all the storage? Like, where's the settings, man? Browse libraries? I don't want to do that. You're confusing me here. Reset the canvas. Oh, it fixes it. Thank the Lord. Okay, let's put the timer back on. We're already 4 minutes in, we're fucked. Okay, let's look at this example here. Alright, so... how did we come up on 4? So we know the min is 1 banana per hour. Why is it so big? We know the min is 1 banana per hour, all the way up to 11 bananas per hour. I'm guessing we'd have to, like, try out all the combinations. So let's say we start off in the middle. I don't know, 5? Let's try 5. That'll be our first guess. We'd see how many hours it'd take to eat all these bananas. Coco would eat the first pile in 1 hour, the second pile in 2 hours, the third pile in 2 hours, and the third pile in 3 hours. So altogether, that is 6 hours. 6 is still, like, right now that's our min. Like, that's a possible answer, but this is actually so easy. What? What the hell? Okay. But just for, like, was it brevity? Is that a word? Brevity? Thickness? Short piece of writing? Yeah, like, for brevity, like, I think we should continue. So, you know, it's, like, at a rate of 5 bananas per hour, she can finish all bananas in 6 hours. That's good, but can we do better? So I guess in binary search we go, instead of 1 to 11, we go 1 to 5, and then we try, I don't know, we try 2. So we try 2, and then we see that she eats 2 bananas per hour. This would take 2, 3, 6, so 9, 12, 14 hours. 14 hours exceeds our limit of 8 hours. So we know that we can't go lower than 2. So we're gonna go 2 to 5. Now, in the middle of that is what? Wait, what? Oh yeah, so, like, so 7, it'd be 3.5 floor, that would be 3. We check 3 next. And now we check 3. Should finish this one in 1, 2, 3, and 4. That'd be 10 hours. It would take 10 hours to complete a banana eating rate of... So 3 is too low. So we move up the range instead of 3 to 5. Wait, we already checked 5. I don't think there's a need to check 5. I don't know. Instead of 2 to 5, we should go 4 to 5, right? I think. 4 plus... Was 4 plus 5 is 9. 9 divided by 2 is 4.5, so we go down to 4. And we see that, like, to eat all these bananas, it would take 1, 2, 3. So that would be 8 hours. That 8 hours fits within our time constraints, and it's the lowest number we could find, so the answer would be 4. That's actually, like, not that bad. Okay. So left equals 1. Because you can't eat 0 bananas an hour. That's, like, stupid. Right equals, I don't know, 3. Equals max of piles. And now we should be able to do the binary search. So while left is less than to right, all right, we're trying to find k. So instead of using m, we're going to use k. So the k rate, wait, and then we need to res equals, I don't know. We're using a minimum number, so let's use a really high number, like 1e9, something like that. It's just a really big number. I could use float infinity, it doesn't really matter. Next, we say k equals... I probably need some type of function that can, like, run through that, maybe? I would say k equals left plus right and like, yeah, so now we have to check that. Should we have a function that does that? I don't know, maybe like let's call it eating rate. Like, it's just gonna go through piles, and it's just gonna output some type of like an integer that's gonna tell me the hour, like how, like, you know, the number. Okay. So def, I'm gonna say eating. Let's call it like E rate, eating rate, and it takes in a number, and we're just gonna say res equals 0. Then we just say, I feel like we can do this in like a one-liner, but no, we're gonna say, so for pile in piles, res plus equals pile. So in this case, it'd be 3. Divided by num Sealing. And we just sealing that shit? I think it's SIEL. No? Oh shit. SI. It's sealing, right? CIEL. Python? I don't really know. SEIL? 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 Sealing? It doesn't have that weird color. SEIL. I have to use math.sealing? SEIL. Does that work? This modulo is divided by. I don't know. This looks weird. Return res. SEIL. CEIL, bro. CEIL. Yeah, that looks about right to me. And then we just go. I'm so stupid. What am I doing? Think. So in this case, it would be like the number here would be 1 plus 11, which would be 12. Divided by 2, 6. So we say like PK for like possible K. Going to equal E rate by K. And so I'm just saying, so basically if PK is less than, if the possible K is less than, what's the thing he gave us? H is less than or equal to H, res equals the max of what? Res and PK, but possible K. There we go. And now here's where we move the pointers. So like if left, no, if L, no. If K, if K, no. Wait, what is this? This outputs the number of hours it takes. So we shouldn't do that. It should be K. This is not possible K. This is the fucking eating rate, dog. Let's go with rate. So if the rate of eating is less than or equal to, no, it's not the rate. This is time. This is time. time it takes to eat all the bananas is less than or equal to the allotted time, we'll consider it as one of our answers. And here's where we move the pointer. So we say if time is less than k, less than, it's great. If the number of time it took us to eat is greater than h, so that means it took us too long to eat all the bananas. What does it mean if it took us just too long to eat all the bananas? It means we need a faster eating rate. So L equals k plus 1. Yeah, okay. And if time is... I can't stand that. And if time is greater than h, that means... like, we is less than h, that means it's a possible answer, but we possibly could go lower. So right equals k minus 1, because we could go lower. And that should, like, output us an answer. I don't know. Let's see. Right under 20 minutes. Did I fuck this up? Nah, it's taking too long. It's not good. Time limit exceeded. What type of malarkey? Do I have to actually do math dot? Why is it not like... I'm a little confused. Wait, why is it... How do I hit a time limit exceeded? Because I did equal to? Okay, let's think. This while loop must be going forever. So while L is less than or equal to R, if it becomes if it's less than R, it means we still have, like, positions to move. If it becomes equal to R, then what? Will it miss something? Like, if, like, L is 3 and R is also 3. Is that the issue? I'm a little lost in that part. I'm clearly doing something terribly wrong. It's very sad. I understand the problem, it's like... the implementation's a bit off. Well... Max! What the fuck? We're supposed to do... min. Still doesn't work. Okay, it's peculiar. Time limit exceed. This is going forever. What's happening here? How do we make this not go forever? Does this function work? Hold up. I gotta test out this function. Shit. Nope, don't don't do that. I have a feeling, oh my god. Print E-rate? Like, I don't know. $11? So that should return 4. It should easily return 4. Yep, it works as expected. That works as expected. Right at 8. Yep. Alright. My E-rate sounds like ecstasy rate or something. But like, it doesn't stand for that, I swear. So this function works while left is less than what, or equal to R? In the time. So if the, like, if the time is greater than the allotted time, what does that mean? If the time is greater than h, that means it took us too long to eat the bananas, right? If the time it took is too long, we need to up our banana eating rate. So we can't eat any slower. We have to eat faster. So right should equal k. Left should, we have to eat faster. So left should equal k plus 1. And if time is less than h, I just put this here. And if time is less than h, if time is less than or equal to h, res equals the minimum res in k. If res is the, yo, I'm actually slow or something. What? Oh. What the fuck? Wrong answer. Oh, output is like has a decimal point. Wait, that's the issue? Oh, because it hit equal to. Oh, okay. Man, I'm a little off, but that was fun. That was fun. That was very fun, actually. Okay, I did that. I'm gonna record a video on that later. I don't know. There's another one I have to do. I need to do like, what is this shit? Valid palindrome 2. Is it 2 sum 2? Oh no, 2 sum I. Is this 2 sum 2? Yes, input is okay. Is this what I mean by 2 sum? Two-pointer? God damn! What the? This is all the 2-pointers? This is not 2-pointers. Get the fuck out of here. This is glitching. What? Oh. Yeah, 2 sum 2. I have to be able to solve this. Okay, reset stopwatch. Given a one index array of sorted integers that is sorted in non-descending order, find 2 numbers that add up to a specific target number. Let these 2 numbers be index 1 and index 2, where... Oh, brother. Wait, okay. Let these 2 numbers be numbers at index. Okay. Where 1 is less than or equal to index 1. 1 is less than or equal to index 1. And index 2, oh, is index 2 is greater than index 1, but less than the number's length. Okay, so index 1 becomes before index 2, okay. Your solution must only use constant space. Okay. Okay. Let's look at this. What am I doing? Holy balls. There's no way to put this to 100. Okay, so let's look at this array here. 2, 7, 11. And t equals 9. Okay. I would imagine, like, we'd have a left pointer at the first number, and then a right pointer. Alright, do we want to have the end or on after? That's a bad example because they're right next to each other. Maybe like here? I don't like this example because they're right next to each other. But let's just see anyway. You would say this is target 9, obviously. It's like, what if it was like 2, 11, 7, and 15? So left pointer here, right pointer here. This would be 13. That's over the target. Oh wait, no, that wouldn't make sense. Because they said it's sorted in ascending order, non-descending, like ascending. What would you say? It says in ascending order, so the numbers get bigger. So is it wiser to start in the? So we do this. Let's just say let's say give an example where t is like 17 or something. We say this is 9. So we know we have to go bigger. So we check. So we move right up 1, and we see that this is 11. This would be 13. That's still too small. And then we go up 1 again, and we see this is 17, so we return it. But if we didn't, then this is a nested for loop, no? Because I start with the smallest number. But like you would break. Like if you ever go, if one of these numbers is already bigger than our t, then we just break. I don't know. I kind of have like a bonk ass solution, but Do I really want to have a nested for loop? Because it would like. Is it smarter to smart? I don't think it's smarter to start from the biggest number. Maybe? I don't know. Does it matter? I don't know. Who cares? Wait, so return. Let's say. For I in range length of numbers, and then for j in I'm sure there's a smarter, more genius way to do this, but this has to start off at like I plus 1. And I would just say like I don't know. Res equals just an array, I guess. And if you can only use constant extra space. Oh, if numbers at I plus numbers at j equals target. The numbers at I plus numbers at j equals target, then what? Just like return. I don't even fucking know. We're using the index, right? Yeah, so like I comma j. I think that's literally all you have to do. And we have to add some optimizations. Like for example, if let's call it sum. If sum is target. Say I'm just saying if sum is greater than target, then we break, because like there's no point. Like you break the inner loop. There's always an answer, right? Isn't this I swear this is the answer. On everything, this is the answer. I'm retarded. Output 0, 1. Expected 1, 2. Oh, it's a 1 indexed array. That is the dumbest shit ever, bro. What do you... Whatever, bro. Whatever. Is it gonna time out? Maybe? Yeah, it times out. Okay. We gotta figure out something better. Okay. Time limit exceeded. How do you beat a test case like this? Only got 5 minutes left. Let's look at this shit again. How do we make sure, like... Wait, what's the issue in that problem we just failed? The problem is Are they all the fucking same number? Yo, dog. They're all the same number? All -1? And target is 2? Oh, there's like 2 ones there. What's the answer supposed to be? God damn. Show less. Um, do I just need a scene? Because you only can add 2 numbers. Like, they're all together. They're legit all together. How do we skip all these duplicates? It's in descending order. It's going least to greatest. Like, if it's the same number, then we should just continue. Because there could be duplicates, like, there could be like 7, 7, but once there's another 7, like, none of that matters. Like, can I say if numbers at I equals numbers at I plus 1? If numbers equals numbers at I plus 1? If numbers equals numbers at I plus 1? Then continue? I have like a off feeling about this because yes, there's duplicates of continue. But what if, like, wait, does it say they're unique? And they have to be the same. So, like, what if the array is like this? Wait, no. No, it's like -1, -1, 3, 3, 3, 3, 7, 7. Target is 14. But clearly the last number, so like the way we're doing it. Oh shit, I just thought of something. So we have like the left pointer here. Yeah, it only could be 2 numbers, so if this wait, so like 3, 3, 3, 3, 3, 3, T14. Okay, so if we had left here and right starts here, there's no need to even look at anything else because we've seen it before. Like, we literally checked all those. I'm thinking, like, if right, so if left equals the same thing ahead, continue, so that means right would just keep moving on until it Wait, no, we have to check left, right. If right equals the same thing ahead of it, like just continue, and it should eventually get here. Check this, and we'll say that like that's 6, it's not 14. Yeah, I think like we should do right. So if j equals j plus 1, then we just continue. So eventually we'd get here, we'd check these, and then it would go to the 7. It wouldn't even hit that 7, it would go to this 7 here. We see that's 10. And then it'd restart with left here, and then right here. And it would just continue again. Is that too slow? I feel like left should equal R. Let's see, is this still too slow? Let's see. What? Unexpected indent block after for statement? Unexpected indent. Oh no. This may be a little faster. Unexpected indent block. Oh, I don't know. I'm fucking confused. List index out of range. J is less than. I feel like it would just skip those now. List index out of range. Yeah, you can't do that. Do I have to really come back to this? Am I fucked? Low key, man. Because if it equals the same, but I guess like once like right gets to the last one, just gonna check ahead of it. Maybe it should start at the back, bro. Maybe it should start at the back. I need to rethink my approach. The answer is like 9, right? So left, right. Yeah, I think this makes more sense. Actually. And then we see this is 17. 17 is way greater than 9. So we move right down. 13 is greater than 9, so you move it down again. And then that's the answer. Is that how you do this? Damn, 18 minutes in? Am I that retarded? I got it the slow way. Two, 3, 4. Target equals 6. Left, right. Oh my god. I think that makes sense though. How would it work in this problem that we just fucked up? Wait, no. That's a long time ago. Take me 18 minutes. So in this case, we need the 1 and a 1 because there's 2. It starts off with the first number. With left over there. Right here. Left plus right? Hold up. Okay. So let's try that. Let's say we had like -1 for like simplicity. -1, -1, -1, -1, 1, 1. Alright, we have to figure out right. It's breaky time. Oh shit, why is Sally calling me?
I'm sorry, speaking.
Oh, you called?
Yeah, I was trying to call you and Dee and get your money all picked up.
Oh,
Listen,
yeah?
you guys put your money in already for your bundle.
Okay, I'll tell my dad when he gets home from work.
Yeah, man, get them guns, man. You can always use them for something.
Alright, I'll let him know. You gotta work right now, but I'll let him know. I'll call you. Alright, peace. Damn, that shit sucks. I just got bulldozed. I just got big bulldozed. Let's what the hell? Hello?
Hi.
Oh, you called?
Yeah,
What's up?
I got you give me a story.
Oh, what's up? Alright, hi.
Hi. Need help.
What do you need help with?
To study.
Okay.
Help me study.
Oh, okay.
You gotta watch me.
Okay.
Yeah.
Why do you sound like a little kid? You good, dog?
Yeah, I'm good.
Yeah, I'm good. You gotta watch me. What the hell? Oh, you alright?
Yeah. Sorry.
Oh, what?
Talking my way.
I don't know. It's kind of funny. Like, what the hell? You gotta watch me. I'm like, what the hell is going on right now? You said what?
Nothing.
Nothing's going on.
No. I'm just laying here.
Oh, she starts studying.
Yeah, I need help.
Oh, okay. I'm here.
How do you wanna watch me?
I don't know. You can join my stream. And you can be in the chat. I'll let you know.
Are you streaming right now?
Yeah. I'm on.
I didn't get the notification.
Oh, yeah. I'm on my 10-minute break. So, yeah. You gotta watch me. Help me study.
Don't phone me.
What the hell? I'm just saying what you were saying.
You're mocking me.
No, I'm not even mocking you. That's exactly how you sound, dog. Oh, okay. Oh, okay. Whatever you say, brother.
I think I'm overwhelmed. I don't know how to start.
Open your computer.
Let's go get it.
You should do that.
Thirsty though.
So you go to the kitchen, you get some water.
It's all over the kitchen then.
Oh, then you find it.
Can you help me find it?
Okay. What?
You have to come here and help me find the kitchen.
Find the kitchen.
Yeah.
I see. Okay. Maybe we could try that.
You tired?
No, I just yawned.
I miss you.
I also miss you. Brevity. Brevity.
Gravity.
Yeah.
Need kisses to wake me up.
You're sleeping still?
No, I didn't sleep.
So why you need to wake up?
Because I'm feeling like sleeping.
You feel like you're sleeping. Okay.
Your voice is nice.
Nice, nice. I try my best. Ugh.
I sleep to your voice.
But yeah, just join the stream. You can hear my voice all day. Next hour and a half.
That's all I have with you.
Well, time to go run, but I guess I'll be back.
Okay. You running here?
That's a little bit far.
I believe in you.
Oh wow.
My baby's a fast runner.
I don't know, man. We got this race coming up. These guys are fast. No joke.
They're a joke. Because you're fast.
They're a joke because I'm fast.
Yeah.
Oh yeah.
They're walking compared to you.
Oh yeah. That sounds pretty good. I don't know if it's true, but it sounds pretty good.
You're so fast, I can't even see you run. I blink and you're going to finish.
Oh yeah. Oh yeah. We gotta go to the race. Actually, that guy beat me. I was playing around. I didn't know he was like. I didn't know this new guy was actually fast. I was gonna be like another one of those slow dudes.
You gotta win back your title.
Oh, of course. Next time. Easy title defense.
Yeah. You should just come put it in.
What the hell, girl?
It's empty.
You maxed out your freak bob stat. I didn't even know he was freak bobbing like that.
You feel good. Oh, I feel it.
Oh, I had the race.
Yeah.
There was no race. I got you. Let's see if
Meet you at the halfway point.
You said what?
I'll meet you at the halfway point.
Oh yeah. Good call.
wanted to know for the dinner if you wanted Academy and Tim to come too.
Oh. Oh Lord. Wait, what are we doing now?
Oh, for the dinner.
Like, who? How? I thought it was just me and you and your mom.
Yeah, but she wanted to know if you wanted Academy and Tim to come because she knows that you like them.
Oh. Where are we going exactly?
I don't know. We gotta figure it out.
Oh. Oh yeah.
But I figured I would ask you first.
Oh, yeah, the break is over officially.
Okay.
Damn, that was fast.
Yeah, too fast. Guess I'll go get my computer.
Yeah, it's good stuff. Good stuff.
Okay, I see you on the stream.
Why do you sound like that, dog? You alright?
I'm sleepy now.
Now you just say you weren't tired, you weren't sleepy, and there you go. Now you're sleepy.
Because I heard your voice and now I'm sleepy.
Oh, I put you to sleep.
Yeah, because you're so soothing.
Oh, I try my best.
Arms right now if I could.
See you what?
I'd sleep in your arms right now if I could.
Yeah, that test must have got you down. You sounded a little bit loopy right now.
I have a lot of brain power.
I could tell. You seem you're out of it.
Yeah. Sometimes school.
Sometimes what?
Sometimes school.
Oh yeah, school is important stuff. Man. Important stuff.
I know. It's just all the grinding starts now.
Oh. Oh, the grinding?
Yeah, I got 2 months of grinding nonstop.
Oh damn, 2 months of straight grind? It's a grind fest.
Yeah.
I gotta sign you up for Grinder.
I don't think they'll take me.
No, they'll take you.
I think that's what they're looking for.
No, Grinders for all. Grinders for all. Didn't you say that, like, your cousin uses Grinder or something? Wait, no. Never mind. I'm tripping. I don't think that's what you said.
Okay. I'll see you there.
Adios.
Bye bye, baby.
Bye bye. You're gonna get your computer first.
I get it.
No, get it right now.
Ordering me around.
Yep. Because you can't be trusted.
You don't test me.
Hell no. You said you're gonna study like a long time ago. It's already past that time.
Because you never called.
What the hell?
I say I need to study with you because I can't study. I'm procrastinating too much.
Oh, I see.
My computer.
Nice. Okay. Yeah. Feel free to text me in the stream, do all that good stuff.
Okay, baby.
Alright, bye. Mwah. Okay. We're back to another to finish this goddamn leak code. Alright, so maybe it makes more sense to do like left pointer here, right pointer at the end. And we see the sum is, see the sum of 1 and -1 is 0. 0 is less than t, so that means we need a bigger number. Yeah, I think that makes sense. That makes more sense. Whatever I was doing is kind of retarded. Oh, let's restart that shit. Okay, let's retry. Left equals. It being 1 index is so silly. Numbers. Length of numbers -1. And what's our stop condition? We're gonna have a while loop, and what do we say? Like, while left is less than r? No, I'm stupid. While left is, yeah, less than r? I think that makes sense. Yeah, wait till I get my glasses. Oh, right is less than. Yeah, because they're gonna keep coming closer together. So right when they're, if they ever cross each other, then like we should finish. Okay, so the first base condition is if numbers of L plus numbers of R equals what, 1? Nope, equals target. Equals target. We get what do we get? If numbers L plus numbers R equals target, then we just return L plus 1, comma R plus 1. God damn it, I don't know why I just keep doing this shit. If sum equals target, then just return that. Like, if sum is less than target, then what do we do? What do we do, brother? What the fuck do we do? If sum is less than target, that means we need a bigger number. So L equals L. Oh no, it was L plus equals 1. Let's try. L plus equals 1. We need to keep doing that until like. But how do we stop it from doing this all the time? It's like, wow, L is... Well, numbers... L is equal to numbers L plus 1. L plus equal 1. If it's the same number, like just keep adding to it. But the sum of our two numbers after all that is less than the target, to move L up 1. And if sum is greater than our target, we need to get a smaller number. So, right, minus equal 1. That makes sense to me, but the thing is, that shit's gonna just, like, this works, but can I just do the same thing? Like, because there's no point checking the same number twice. There's literally no point. No, R. I feel like I just don't even need to do that. Because in this case, it should just do this equals 0. It's less than. And then we just say this is the same. I might need that. There's no, it's not like the same. Oof. I got this one wrong. I got null. I got null. What the hell? I got null? I got null? Bro, what? What number is this? Okay, let's look at this example. 0, 0, 3. Target is 0. 0 plus 0. So we got 0 and 4. Zero and then 4 is 4. That's greater than, so we need to make the number smaller. So left. So right comes down 1. So I should have moved this up to 0. I would have moved this up. Oh, I see. You can't do that regardless. This works. But it doesn't, it's gonna time out, I think. I still think there's like a big issue with the whole like timing out thing. Nope. 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 Sum is less than the target. If sum is less than the target, this is crazy. L plus equals 1. If the sum is less than target, move. That's cool. It took 8 minutes. All right. We need to record a video now. That was fun. Let's do this cocoa eating banana shit. Wait, no. Let's do this one first because, like, we just did it. Okay. Let's scroll down here. The missions, solutions, description. Okay. It took me a while to like remember how to do that. Yeah, this is actually so easy. And then cocoa eating bananas is next. So let's reset this. Wait, are you sure you want to what? Retrieve your last submitted code. Okay, we're gonna make this video. Okay. Let me take a piss and get a hoodie on. Take a pissing then. Take a pissing then. Go to work. Gotta go to work tomorrow. Gotta go to work. Bye. We're back. The debit card has shipped. The debit card has shipped. That's nice. Is Sophia in the chat? I don't know. What am I doing? I'm getting distracted as like fuck right now. Yes, E. Yeah, they be cooking me like this. Oh shit. My bad, my bad, my bad, my bad. Yo, okay, you're right. I need to lock in. I was looking at something like I'm gonna call you during the break actually. All right, yeah. Let's lock the fuck in, bro. Let me pause the music. Okay. Got distracted like holy hell. Okay. Is my like oh my god. I guess this is like decent. It's a good angle. Let's see. I think we're good. Okay. So it sucks my like all right. It sucks that like yeah, you look fine. Oh, Sophia, I don't know if you check your Instagram or your messages. You know how my Instagram account got deleted for like child exploitation or something? They said that people that falsely accuse you of that it makes you look even better, and you can actually get you can get like if you look what I sent you, we should try that. My audio is glitchy. Wait, you can't hear me? My audio is bad. That's actually really important because I'm trying to make a video. Glitchy, it's glitchy. Okay, give me a second. Uh, it's glitchy. The message. Oh yeah, but the audio being glitchy is not good. Like, what's wrong with it? Hello, hello, hello. Oh, it's. I sound like a robot. Okay, I'm gonna have to fix that. Give me a second. I may have to unplug my mic. Wait, it sounds good now? I don't sound like a robot anymore? It's straight? It's good? Send one more message confirming it's good. I want to make sure it's not delayed. Hello, hello? I don't know. You straight? Okay, nice. Okay, don't type in chat like for right now because I gotta make this video. Damn, should I show off the Kif hoodie? Do I look kind of based? Kind of based. The only thing is, it's like you can't see it because like my camera and shit. Like, and if I tilt this down, like I'm not really. I feel like this angle looks a little wonky because you can see like all that shit in the background. Is this angle better? I don't know. I feel like I'm too far. I feel like this angle is like better, but you can't see my hoodie, which I don't know. I kind of want to show it off. All right. Okay. Damn, I told her not to type, so she can't even respond. Anyway, let's do this fucking problem. Oh no. But I like when it's chest up. Chest up. What the fuck? Chest up like what like this? I don't know. Chest up? When it's chest up, like here? Like it's my chest? Like this angle is good? I don't know. Just text me on my phone. Please tell me. Your body itself? What the fuck? Like it's like this? Like this? You look good now? Oh, okay. Alright, sure. Okay, so I'm gonna make this video. Alright, how do I want to explain this? Given a one index array of integers numbers that is already sorted in non-ascending order or ascending order, find two numbers that add up to a specific target. Let these two numbers be numbers at index 1 and numbers at index 2. Where index 1 is greater than 1 but less than index 2. Index 2 is greater than index 1 but less than the length of the numbers array. I'll know a little higher. Like that. Return the indices of the two numbers index 1 and index 2 added by 1 as an integer. What? Added by 1 as an integer. Added by 1 as an integer array. Index 1 and index 2 of length 2. These tensor generators are exactly one solution. You may not use the same element twice. Wait, what? You may not use the same element twice. Okay. 2, 7, 11, and 15. Excuse my piss poor handwriting. 2, 7, 11, and then 15. And we have T for target, which would be 9. Okay. Okay. I guess I can start now. All right, hello everyone. Today we're going to be solving LeetCode 167 to sum input array is sorted. So given a one index array of integers number that is already sorted in non-descending order, find two numbers that add up to the specific target. Let these two numbers be numbers of index 1 and numbers of index 2. And basically, where index 1 is greater than or equals to 1, but less than index 2. Index 2 is greater than index 1, but less than the length of the numbers array. Return the indices of the two numbers, index 1 and index 2, added by 1, because regular indices are 0 indexed, but they said that this is a 1 indexed array, so that's why we're adding 1. And return it as an integer array of length 2. The tests are generated such that there's exactly one solution. You may not use the same element. Okay, so let's get into the first example here. As we can see, this indice would be 0, 1, 2, and 3. And the number target is 9. So as we can see, 7 plus 2 equals 9. But since it's one index, our answer should be add 1 to the 0. So it'd be 1, comma, and then add 1 to the 1, and that'd be 2. And this should be the answer. But the question is, how do we find the answer in the most efficient way? And the answer is a two-pointer solution. What we're going to do is have a left pointer at the beginning of the array and a right pointer at the end of the array. And we do this because there's a useful hint here. It says that it is already sorted in non-descending order, i.e. ascending order. So what does that tell us? That tells us how we should move the pointers. So let's say we started off with the left at the beginning and the right at the end. We see that 15 plus 2 is 17. 17 is greater than our target of 9, so what should we do? Well, what pointer should we move? If it's too big, then that means we need to find a smaller number. So we know that we should move one of these pointers. And if we move the left pointer up, that would actually be bigger. So 17 plus 15 would be 22. So what we should do is, if it's too large, move the right pointer down because it's in ascending order. So the number before the right pointer is always going to be smaller. And we do that. And so now we see that 2 plus 11 is 13. 13 is still greater than 9. So what we're going to do is move the right pointer down by 1 once again, because we know that we need a smaller number. So now that r is at the 7, we see that 7 plus 2 is 9. That's equal to our target, which is t. So what we should do now is just return L and R. But remember, it's one index, so we'll add 1 to each of those numbers. Hopefully that makes sense. And if you have any questions, just comment down below, and we're going to get into the actual code, like what to do here. So first we zoom in so everyone can see. So first what we want to do is create our pointers. So we're going to say L equals 0, R equals the length of numbers minus 1. And we do that because arrays are 0 index and the length is not. So we have to do minus 1 to get the last value in the array. And we're going to use a while loop. We're going to say while left is less than R. And we do that because we want to keep going until we either find the match, the two numbers that equal the target, or we go out of the for loop when the two pointers cross each other. So let's say well, everyone has an answer, so we'll eventually find it. But let's say there was a situation where there was not an answer, and this was too large. Let's say this was like an 8 or something. 8 plus 2 is 10, which is above the target. If we move right down, now right and left are at the same pointer, and we should stop. So that gives us, make sure we never hit an infinite loop. Next, what I want to do is create a variable called sum with a capital S, because lowercase s is taken by Python. So sum is just going to equal numbers at L plus numbers at R. And now what we want to do is say if sum is equal to the target, then we return L plus 1 because it's 1 indexed, and R plus 1. It's a little bit weird. I'm not sure why they did that, but just followed rules. So it's 1 index, so we add 1 to it. And here's the fun part where we move the pointers. So as you remember, if sum is greater than the target, as you guys remember here, remember when, let me move this back. So let's say when we first start, the sum here would be 17 because the right pointer is at 15 and the left pointer is at 2. It's greater than our target 9, so we need to move the right pointer back 1 position to get a smaller number. So what we should do is say, if the sum is greater than our target, I forgot the little if. If the sum is greater than our target, we need to say right equals, or minus equals 1. And the same thing for the, if it's too small. So if sum is less than target, what do? Let's see right here. So let's say if sum is less than the target, let's say for whatever reason the target was, this is a bad example to show that, but let's see. Less than the target. Okay, let's say for whatever reason our right pointer was here at the 11 and our target was now like 17. If we see that 2 plus 11 is 13, we know that the left pointer, oh wait, no, sorry. Okay, okay, I'm gonna have to cut it right there. All right, and we do the next part. So we say if sum is less than our target, what do? So let's go back to our example. So let's say, let's look here and change it a little bit. Let's say that our answer was actually 22. Let's say target equals 22 in this scenario. We have our right pointer here. We see that left plus right will be 17. 17 is less than our target of 22. So what do we need? We need a bigger number to bridge the gap between 17 and 22. So what we're going to do is, since we know the array is in ascending order, we're going to move our left pointer up 1. So if left moves up to 7, we know we're guaranteed to have a bigger number. So now we're going to check, and we say that 7 plus 15 equals 22. 22 is equal to t, which is the target, and we'd return the 2 indices plus 1. So we'd say that left plus equals 1. Hopefully that made sense. And we should be able to run this and everything should be fine and dandy. Let's try it out. Runtime error, target is not defined. Oh, I used the capital T instead of a lowercase t. Okay, there we go. Let's submit. Ah, I did it again. I used target. Let me fix all these. There we go. And we were able to solve the problem, and it was actually a pretty efficient solution. We beat 85% in runtime. So hopefully you guys learned something from this video. Peace. Sophia, was that good? Did that make sense at all? Or should I redo it? I'm thinking maybe redo it. I don't know. That was low-key. Was that dog shit? I don't know. Did that make sense? I think that was good. First try. I don't know. You take advantage of the fact that it's. I'll watch that, and if I need to redo it, I will. I kind of didn't like that one personally. It was just okay. I don't know. Hopefully that made sense. I don't know. I'll watch it back. If it's like really bad, then I'll have to redo it. But for right now, let's do the Coco eating banana shit. This one's actually pretty fun. Let's look at Scally Draw. Coco eating bananas. How do I want to explain this? Okay. I feel like I could solve this. I guess. Okay. I only have 23 minutes or seconds left on my break until the break, so I might just get the break and say fuck it. Um I get my 10-minute break. I get my 10-minute break. Okay. Whatever. Gonna have some fun here. Knight f4, check. Knight f4, king g4. Oh, this is done. What am I doing? Oh, a3. White to move. Maybe like g4. Wait, what do I do? Oh, I'm silly. Damn, Sophia disappeared. She done disappeared on me. Was that, I don't know, did you see me record? Was that good? Was that decent? I don't know. I don't know. Like checkmates now? I feel like, I don't know. I see bishop g2. And that just looks like appealing. Bishop g2. King g2. Yeah, it's a check. Wait, what's the follow-up? I don't know. I thought we just pick up the queen. My audio is glitchy again. My audio is glitchy. Was my audio glitchy during the recording video? Oh lord. I'm not really sure what's going on. Hello, hello, hello. Hello? It's glitchy? It does sound kind of glitchy. Oh, yeah. Huh. I guess I'm just gonna unplug the mic. Hello, hello, hello. Does it sound better now? Does it sound better now? I surely hope so. I'm so retarded. What's wrong with me? I hope my mic sounds better. Oh, yeah, better. Yeah, okay, nice, nice. I swear, if that video is glitchy, I'm gonna be like kind of upset. Not really. I just redo it, but it's like whatever. I haven't done this in a while. I need to record that shit. It's kind of dog. That's kind of a bad video. I could play checkmate. What? Oh, beep. I hate this shit, man. Checkmate. Yeah. That E. E2. Knight E2. Bishop E2. I don't know. How is there a checkmate here? How the fuck is there checkmate here? How the fuck is there checkmate here? Am I tripping nuts right now? I feel like, I don't know. Knight F3? Knight F3 check? Calculate the correctly bin material. Is this not just like... Go here. Is there a way to end this with checkmate? I mean... Maybe? Rook H8? Rook A8? King H7? On G5? H check G5? Yeah, I don't fucking know, man. I think this just makes the most sense. I could win a rook. I feel like that's not like... Probably checkmate's better. Alright, he forked me. I'd rather not give up my my queen? Like I wouldn't go like queen d2 and then bishop e2. Oh yeah, it makes sense. Yeah, just win a bishop like that. This is definitely just like a queen. I don't know. Can you g1? King takes g1. Yeah, I think yeah, that's it. Okay, that's a free bishop. I mean, it's a free rook. That's like what? I think it's one of those situations. You have to give up the rook to even like I don't know if they can do anything. This is just checkmate. Black to move. Oh, black to move. Fuck, dude. I don't know. Oh. Wait. I mean, I know that's the move, but wait, what's the follow up? Because he goes g2, g1. After g1, then what? Oh, then we just did that. Ah, black to move. I don't know if it's like black to. This looks. I'm looking at f4. Where does he go? h5. h5. If he goes h5. I don't know. That's mate. Hold up. That is mate. That's crazy. That's crazy. Okay, let's make a new video. Okay. Oh, I'm fucking tired. Alright, hello everyone. Today we're going to be solving leak code 875, Coco eating bananas. A very fun one. Coco loves to eat bananas. There are n piles of bananas, and the ith pile has piles I bananas. The guards are gone and will come back in h hours. Coco can decide her banana per hour eating rate of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly, but still wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within h hours. Alright, so we're going to quickly go over the example and explain why this is the right answer. So, the output is 4, and let's see. Let's say she eats at a rate of 4 bananas per hour. That means she would finish this pile. Oh, sorry. She would finish the first pile in 1 hour. Because remember in the directions, it says that if the pile has less than k bananas, she eats all of them instead and will not eat any more during this hour. So it takes her exactly 1 hour to eat 3 bananas because she has an eating rate of 4 per hour. How many hours will it take her to eat 6 bananas? It would be 2 hours because in the first hour she eats 4 bananas, but she won't eat any more in that hour. And the remaining hour, there'll be 2 bananas left, and she'll eat those and not eat any more in that hour. Hopefully that makes sense. Next, we see that for 7 bananas, she would eat 4 in the first hour, then 3 in the next hour, so that'd be 2 hours in total. And for 11 bananas, what do we think it is? it would be 3 hours because she eats 4 bananas the first hour, 4 bananas the second hour, and 3 bananas the third hour, and that gives us 11. And all of these summed up would be, this would be 2 plus 2 is 4, 5 plus 3 is 8. That means it took Coco exactly 8 hours to eat all of these bananas. But let's see what happens if we gave her a banana eating rate of, let's say, 3 hours. Because we know this is the answer, but let's pretend we didn't know. So if she had a banana eating rate of 3 hours, it would take her 1 hour to eat the first pile, 2 hours to eat the second pile. Here, it would actually take her 3 hours to eat 7 bananas, because the first hour she eats 3, the second hour she eats 3, but that would leave 1 more banana left, and she can't eat any more within that hour, so she'd have to stay for a whole additional hour just to eat 1 banana. So that leaves us at 3 hours to eat 7 bananas. And once we get up to 11, she'll eat 3 bananas the first hour, she'll be up at 6 bananas in the second hour, 9 bananas in the third hour, and 12 bananas on the fourth hour, but there's only 2 bananas left. So it would take her 4 hours to eat 11 bananas. And we sum all of this up, and what do we get? We get 10 hours. So with an eating rate of 3 bananas per hour, it would take Coco 10 hours to eat all of the bananas in the pile. But the guards are back in 8 hours, so she doesn't have enough time. So that's why the answer is 4, because 3 takes too long, but 4 is in the constraints of 8 hours. All right, hopefully that makes sense, and I hope elucidate at least the probable statement. So let's get into how we actually solve it. So the first piece of information that I like to look at is, what are the min and max? What are the bounds of our possible answers? So what is the minimum amount of bananas Coco can eat per hour? She can't eat 0 bananas per hour, but she could eat 1 banana per hour. So if we set the min is 1, and now what is the max? What's the max amount of bananas per hour Coco can eat, and we can guarantee she can eat all the bananas? Well, it actually just be whatever the max number is inside of the array. In this case, it's 11. So the max would be 11 bananas per hour. Because if she ate 11 bananas per hour, it would take her 1 hour to finish this one, 1 hour, 1 hour, 1 hour, and that would give us 4 hours in total to finish the pile. But we want to know, what is the minimum rate of banana eating per hour to eat all the bananas within H hours? We see that the max, we could eat them at 11 bananas per hour, but it would take 4 hours, and we have an allotted time of 8 hours, so we can easily eat less bananas per hour, and maybe take a bit more time, and hopefully that makes sense. Okay, so since we know the min and the max, what we're going to do here is something called binary search. I would recommend, if you haven't heard of binary search, maybe trying the binary search easy question, I believe. This is a bit more advanced, and then come back to this one. I'll link it in the description. Okay. So with that being said, we have our min, we have our max of 1 and 11. What we're going to do is, we're going to use binary search to determine what is the most optimal banana eating rate per hour in between this range that we have predefined. So what's the most efficient way to do that? As we know in binary search, we always find the midway point. So we say, what's 1 plus 11 is 12, and what's the middle of 12? It's 6. So we are going to look at how much time will it take Coco to eat 6 bananas, to eat all of the bananas in a pile with an eating rate of 6 bananas per hour. So we're going to test that out really quickly. We can say it would take Coco 1 hour to eat 3 bananas. It would take Coco 1 hour to eat 6 bananas, because that's in her eating rate per hour. It would take Coco 2 hours to eat 7 bananas, because she eats 6 in the first hour and there's 1 left, so she has to stay there for an additional hour. And it would take her 2 hours to eat 11 bananas because she eats 6 in the first hour and then 5 in the second hour. And what does that give us? 2 plus 2 is 4, 5, and 6. So with a eating rate of 6 bananas per hour, it would take Coco I'm covering that. It would take Coco, let me erase some of this. 6 hours to finish all of the bananas. And we see that we have an allotted time of 8 hours, but we know we can get it done with an eating rate of 6. So what do? What does that tell us? That tells us that with an eating rate of 6, we could finish all the bananas, but we have more time. So what should we do? We will all right, so since we know that with an eating rate of 6 bananas per hour, let's just call this ER for eating rate. And this is the, let's say, time. So it took her 6 hours to eat all the bananas in the pile with an eating rate of 6. But we have an allotted time of 8 hours. So what should we do next? Now, take a minute to pause if you want to think about it yourself, but let's quickly go over it. So what we're going to do is say, if we have an additional 2 hours to spend, how can we optimize this? What we're going to do is to decrease the eating rate and see if we could find a more optimal eating rate per hour that would allow us to eat all the bananas within our 8-hour time constraint. So we know that 6 can get the job done. So prior, our minimum was 1 and our max was 11. But now, since we know that 6 can get the job done, our new min should be 1, and our max should be 5. And why is that? Because if we can guarantee she can eat all the bananas within 6 hours, we know that that's a possible answer. We'll save that. And now we'll explore the remaining range between 1 to 5 because we have not checked those numbers, and those are all less than 6. All right. So we see 6 is a possible answer. I'm just going to keep that, 6 is a possible answer. I'm going to keep that right here. And for eating rate, we're going to do the same thing here. So what's 5 plus 1? That's 6. 6 divided by 2, because you always want to find the midway point. So divide by 2. And that is 3. So now we're going to check how many bananas can Coco, how long will it take Coco to eat this entire pile with an eating rate of 3 bananas per hour. All right, and we can just quickly do that. So it would take her 1 hour to do the first pile, 2 hours, 3 hours, and 4 hours. And we see that this would be 10 hours. So it takes her 10 whole hours to eat the whole pile, but the guards are back in 8 hours. So what does that tell us now? You can pause the video and think about it here. But that tells us that the eating rate of 3 bananas per hour is too slow. So now we know our minimum has to be greater than 3 because 3 is too slow. So we try that and we say our min is going to be 3 plus 1 because we already checked 3 and found out it was too slow. So our min is now 4 and our max is now 5. It stays the same at 5. Our max, oh Lord, let me rewrite this. Our max stays at 5. And remember, we're going to do the same algorithm again. So 4 plus 5 is what? 9. 9 divided by 2 is what? 4.5. So as we can see, 4.5. But what we always do is floor, because she can't eat half a banana. So we're going to just floor it, and we're going to change this to 4 because we don't want to deal with any decimal points. And we see 4. So now we're going to check with an eating rate of 4 bananas per hour, how long will it take her to finish the pile? And as we can see, it would take her 1 hour to finish the first pile, 2 hours to finish the second pile, 2 hours to finish the third pile, and 3 hours to finish the fourth pile. And we add this all together, and we get, drum roll please, 8. It would take her 8 hours with an eating rate of 4. And as you can see, we can't move the pointers any farther because we reached the answer. We see that she can eat. Wait, hold up. So as we can see, with the eating rate of 4 bananas per hour, we are inside the time constraint of 8 hours until the guards come back. And our previous answer was 6. So we had 6 bananas. She was able to eat an eating rate of 6 bananas per hour and eat all the bananas. But now we can do an eating rate of 4 bananas per hour, and she's still able to eat all the bananas. So that is going to be our new answer because we want to return the lowest. So now we have the number 4. All right, and in the last iteration, you see that 4 allows us to eat all the bananas. And if it's less than, we're going to try it one more time, and we're going to say, what's our min? What should our min be? If we increase our min, since we know that 4 is a possible answer, to 5, and our max is also 5, that means that the left and right pointers are at the same position. So we'd get out of our binary search, and we'd return what the lowest answer we found. Hopefully that makes sense. And if it helps illustrate it a bit better, imagine we had like a number line. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And when we first started, our left pointer was at 1 and our right pointer was at 11. We added them together, got 12. We got the midway point, and we landed on 6. 6 was our mid. We saw that she can eat all the bananas within a allotted time of 6 hours. So we know we don't have to check any number above 6. So we move our right pointer down to m minus 1. So right comes all the way down here. And as you can see, that's why it's so efficient, because we essentially cut out all of these numbers and we didn't have to check them. And now we're just dealing with between 1 and 5. And we keep doing this algorithm until the 2 pointers meet each other, and we break out and we return the most favorable answer. And I guess just for I'll continue to show the number line just to be more concise. So as we do the same algorithm. 1 plus 5 is 6. 6, and then it gives us a new midpoint of 3. So this would be our mid. We found that with an eating rate of 3 bananas per hour, it would take her 10 hours, which is too long. So we know that anything less than 3 is going to be an even greater time to eat the bananas. So we'll move our left point up to 4. And now left is now at 4 and right's at 5. And as you can see now, we've skipped all of these numbers. We've only done 2 searches, and we've eliminated 80% of all the possible numbers. And we do it one more time, and we check the 4, and we found out that was the answer. And there's no more numbers in between, so that's why we stopped the algorithm. Hopefully that makes sense. I love the number line explanation. It helps me so much. And let's get into the code. Okay, so what I like to do first is say, let's make this a bit bigger so everyone can see. What I like to do first is to make my pointers. So because we know we're going to be using those. So left just represents the minimum number, so that'll be 1. And our right pointer will equal max of piles. All right, now we're going to have a helper function, and what it's going to do is to help calculate what is the maximum number, what's the amount of time it takes. All right, so we're going to have a helper function that's going to tell us what is the eating rate at whatever Okay, okay. So we have our left and our right pointer, and we're now going to have our while loop. So while left is less than right, we're going to calculate our mid-way point. So as you remember in the number line, mid was always the left plus the right divided by 2 floored. So how do we write that? We say our midway point is equals left plus right divided by 2 floored. So we just used a floor division or integer division, and that would give us our answer of our midway point. But as you remember in the example, I did it manually, but we had to calculate at each midway point, as you see when we saw 6 was our midway point, we had to calculate how long it would take Coco to eat all the bananas. And what we're going to do is have a helper function that's going to tell us the eating rate. So we're going to have a function called define, and we're going to call it maybe, let's just call it E rate for eating rate. So it tells us how long it will take Coco to eat bananas at a certain rate. And it's going to take one number as a parameter. All right. And what it's going to do is just sum up the total time it takes Coco to eat the bananas. So we're going to have total equals 0. And we're going to say for pile in piles, total plus equals ceiling of the number of bananas, well, the pile that she's eating divided by the eating rate or the num. And as you see, it's that's exactly what we did up here. So let's say she had an eating rate of 6 when we were checking. We'd say that 3 divided by 6 is what? 0.5. We ceiling it up, so that would be 1 hour because she can't eat. We're working in 1 hour intervals. So as you can see, this would be 1 hour. What's 6 divided by 6? 1. If we ceiling it up, it stays at a 1. What's 7 divided by 6? It would be like 1 point something. And we ceiling it up, and it would be 2. And as you can see, that gives us the eating rate per hour no matter what, because she always has to wait and finish the hour. So that's why we do that. And then after that here, we just return total. And that should return us our eating rate. Okay. So we're going to make a variable called ER, which stands for eating rate, or we can say just rate maybe. So rate equals our E-rate function with M, because M is our midway point. So now we know how long it takes Coco to eat all the piles of bananas in M hours. All right. So now all we're going to do here is, this is where we move the pointers. So as we can see, if we're going to say if the rate that she eats, actually this maybe should be called time. Let's call this time, because this is the total time it takes her to eat at that rate. So if time is greater than h, which is the allotted time until the guards come back, what do? That means we know that so if the time is greater than h, which is the allotted time we have until the guards come back, what does that tell us? That tells us that our eating rate is too slow because it's taking too long to eat all the bananas. So what should we do? If our eating rate is too slow, that means we know that everything behind our midway point is not a valid answer. Remember when we were looking at 3 here? We saw that it would take Coco 10 hours to eat all of the bananas, which is too long. So anything less than 3 or equal to 3 is not a valid answer. So what we're going to do, just like we did here, we move our left pointer to whatever the midway point is, plus 1. So we're going to say left equals m plus 1. All right, next we say if the time that it takes Coco to eat at that eating rate is supposed to be greater than. If it is less than the amount of time it takes Coco to eat all the piles. All right, wait. Shit, let me go back. All right. So first, we're gonna say my God. This is crazy. I might have to re-explain this. It takes a long time. I'd read the problem correctly. I think I need to re-explain it. Because I don't even feel like... I feel like that explanation was kind of dog shit. Let me try it. Let me try that again. I had to get the hang of it. That was like a good practice one. I don't like how that came out. All right, so let's look at this example here. What I like to do first is let's look at the bounds. What are our possible answers? So let's look at something like our min. What is the minimum number of bananas Coco can eat? Well, it would be 1 banana per hour because she can't eat 0 bananas per hour. So that'd be 1. But here's a bit of a tricky part. What's the maximum that she can eat? It would be whatever it is the maximum number in the piles. In this case, it would be 11. As we can see, 11 here. So the maximum number that Coco can eat is 11 bananas per hour because she would be able to finish them in 4 hours because that's the length of the array. I take one eating rate of 11. She can eat every single pile in only 1 hour. All right. And so now the question is, how do we find what is the most efficient way to eat the bananas in H hours from our range? We see that the min is 1 and the max is 11. So let's quickly draw that out here. I might skip ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, 11. Okay, so we have our number line here, and these are all the possible answers. And our left pointer should be at the minimum possible answer, and our right pointer should be at the maximum possible answer. So, as you guys remember in binary search, what do? We find the midway point. So, we do the left plus the right divided by 2. Because you go smack dab in the middle, because we don't know what number it is, so we always try the midway point. So what's 11 plus 1? 11 plus 1 is 12. 12 divided by 2 is 6. So that gives us a midway point of 6. So we have a mid of 6. Now, what do we have to do next? M is going to represent a possible answer, which is going to be the eating rate that Coco is going to be eating all the bananas. But we have the eating rate, but we have to know what is the total amount of time that it takes her to eat all the piles of bananas at this eating rate, in this case 6. So what do? We'll have to iterate over the piles of bananas, and we can make a helper function for that. And what we're going to do is use our eating rate and divide it by the pile and ceiling it. And I'm going to explain why we have to do the ceiling. So let's say we had 3 divided by 6. That would be 0.5. She can't eat banana in 30 minutes because we only work in hour intervals. So we ceiling it up, and that would be 1. And as you see, just like in the regular example, it takes her 1 hour to eat 3 bananas because we always have to ceiling up because she has to wait until the end of the hour to go to the next pile or stay on the same pile and eat the remaining bananas. So we're going to have a helper function that's going to do that for us. So we see 6, and we're going to calculate how many hours it takes Coco to eat all the bananas at an eating rate of 6. Let's quickly do that. So let's say we use our function, we ceiling it up. This would be 1, 1, 2, 2. So that would be 6. So that means it would take Coco 6 hours to eat. Let's write this here. It would take Coco 6 hours to eat all the piles of bananas at an eating rate of 6, because that's where our midway point is. All right, and what does that tell us? 6 hours is less than the allotted time 8, but this is a possible answer, so we're going to save it. But where should we move our pointers? We know that 6 can get the job done, so should we check anything greater than 6? I'd say no, because if 6 can get the job done, why would you want to eat at a higher number if we're looking for the lowest number possible? So what we can do is actually cross out all of these numbers. We don't even have to check them. And we already checked 6, so our new right pointer should be m minus 1, because we haven't checked 5. So now our right pointer should be at 5. And we've essentially crossed out half of our array already. And we're going to follow the same algorithm here. So our right is at 5 and our left is at 1. We say that what's 1 plus 5? It's 6. And we see our new midway point is... let me quickly erase that. Our new midway point would be 3. We see how long does it take Coco to eat all the bananas at an eating rate of 3 hours. So as you can see, we got 1 hour, 2 hours, 3 hours, and 4 hours. And if this part is a little bit tricky, just always remember the pile divided by the eating rate ceiling, because she has to wait until the hour ends to move on to the next. So we add up all these numbers, and what do we get? This equals 10. 10. So a possible answer here is 10. 10 is greater than 8. That means the guards will come back while Coco is eating the bananas. So what does that tell us? That tells us that should we check 1 or 2? No, because it's going to be even greater amount of time to eat all the bananas. So we could essentially cross out all of these numbers and move our left pointer to m plus 1. So now our left pointer is at the 4. And here, this is the last time. We do it one more time. And we say that what's left plus right, that would be 9. And we do integer division divided by 2. And what does that give us? It would be 4.5, but since we're doing integer division, it floors down, and that would be 4. So now we check, how long does it take Coco to eat all the bananas at an eating rate of 4? We say it would take her 1 hour here, 2 hours here, 2 hours here, and 3 hours here. So 2 plus 2 is 4, 3 plus 1 is 4, 4 plus 4 is 8. So it would take Coco 8 hours to eat all the bananas. And that means the guards will come back soon as she's finishing. So she can actually finish all the bananas within the allotted time constraints in 4 hours. So we look at our possible answers, and which one should we choose? We're looking for the lowest possible eating rate, so we should choose 4. 4 is our golden ticket, and that would be the answer. And our stop condition in our while loop would just be while L is less than right. Because if it's equal to the eating rate, we're going to move the left pointer up, and they'll cross each other. When their pointers cross each other, that means there's no more numbers to check, therefore we end the for loop. But we already captured our answer, which is 4. All right, hopefully that makes sense, and let's get into actually solving it. All right, so the first thing I like to do is make our pointers. So we say left equals 1, right equals the left of numbers minus 1. And we do minus 1 because the length of the array is not 0 index, and the arrays are 0 index, so we have to subtract 1 to get the last value. Next, what we should do is, let's create a res variable. This is where we're going to check our answer. We're looking for the minimum number, so we can just make it a big number. So let's just say, like, 1E9. It's a really big number. And because we're always going to find the minimum. It's just a safe number. You could use it float infinity. It doesn't really matter. Next, what we're going to do is create that helper function. When we're given, we want to check one of our answers, which is a possible eating rate. We need to check how long it takes to eat all the bananas. So this is going to be a helper function. We're going to say, let's call it eating, maybe? Eating, and it's going to take in a number as a parameter, which would just be the eating rate. Maybe like total eating. Let's just call it time. Time, that's fine. So the amount of, this is the total time. Let's just call it total time that it takes. And we're going to get a num, which is the eating rate. So here, what we're going to have here is make a variable called total, which is what we're going to return. So total equals 0 in the beginning. And we're going to say for piles, for pile and piles, just like we did when we were iterating over this, we're going to say total plus equals ceiling of the pile divided by our eating rate, or num. I believe this is the ceiling, S-I. Is it S-E-I-L? S-I-E-L? Ceiling? I believe it's ceiling, yes. And that would return us the total number, the total time it would take her to eat all the bananas. All right, so since we have our pointers, we have our helper function, let's get into the fun part. So we're gonna have our while loop. So while left is less than right, so we don't want our pointers to cross, that's when we come out the while loop. As you remember, what's the first thing we did? We found the midway point. So we're gonna say m equals left plus right integer division 2, because we don't want to have any decimal points. Now what we want to do is have a variable called time, and this could be the total time at this eating rate. And as you remember, we made our eating rate function, so we're going to say time equals total time, and our parameter, what do you guys think? It should be m, because as you remember here, when 3 was our midway point, we had to check how long it would take Coco to eat all the bananas with an eating rate of 3 hours. And this total time function will return that for us. And it's a lot cleaner than to have writing all the logic inside our while loop if we could just have a little helper function. So now here's the fun part, and it trips a lot of people up, so make sure if you need to rewind the video, no problem. We're going to say, if the total time it takes Coco to eat the bananas is greater than h, which is the allotted time until the guards come back, what does that mean? Remember when we looked at 3? With an eating rate of 3 hours, it took her, or 3 bananas per hour, it took her 10 hours to eat all bananas. So what does that tell us? That means that anything less than 3 or equal to 3 is too low. So if time is greater than h, we have to move our left pointer to equal m plus 1, because as you remember, m was at 3, but we already checked 3 and found out it was too slow, so now we want to check a new number, which would be 4, which is like unmarked territory. All right, and let's do the inverse. So if time is less than h, so that means we've eaten all the bananas under or equal to the time that was allotted. As you remember, we had at an eating rate of 4, we finished them in exactly 8 hours. That's why we need the equal to sign to account for if we hit right on the dot. And what do? This is how we save our answers. Remember, we save the answers here on the left side, but what we're going to do is say, if the time is less than the total time allotted or equal to, that's a possible answer. So res is going to equal the minimum of res and our current eating rate, which would be m. So we're going to save it, and this makes sure we always have the least value, or the smallest possible value. But we also remember we have to move our pointer, because as you remember in the first example, we had an eating rate of 6 and it took 6 hours. That's less than, but we still have to move the pointer. So if we find an answer that's less than, we know that everything greater than that number, we don't have to check. So at, for example, 6, we move our right pointer down to m minus 1. That's how it got to the 5 here. So we say that the right pointer equals m minus 1. All right, and that should be pretty good. And we go here and we say return res. And hopefully we didn't mess up anything. That'd be amazing. But let's try it out and see what happens. Numbers is not defined. It's always something. It's piles. All right. Hopefully that was our only error. Let's see how we do. I knew I spelled that wrong. I had a feeling. It's S-E-I-L. So sorry for the small mistakes. I swear that should be the rest of them. Oh my god. Oh, all right. Quick fix. As you remember, we added total. We've accumulated all of our piles in a total, but what we forgot to do is return the total. We have the total here, but we forgot to return what that number would be. It's always the small mistakes, so always make sure to check your code. Don't be like me. All right. And this should work. Yo, what the fuck? What? If the time is greater than... What? 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 I'm a little baffled. What? What? Yo, I'm actually like slow or something. What? I did the problem wrong. Invalid syntax. Yo, what the hell? Am I like retarded? I got 3. I got 3. What? Why would I get... How the fuck do we get 3? Yo, I'm tweaking heavy. Am I like retarded? How the hell do we get 3? It's taking way longer than I expected. If time is less than or equal to h. What? If time is less than or equal to h, res equal to min. I literally just solved this answer. It's the same shit. What? This is literally the same thing. Did I do this wrong? For pile and piles, total plus equal S. What? I legit don't understand how this is wrong. Equal to? It's equal to. How the fuck do we get? How do we get here? How did we get here? How did we get here? I'm an idiot. It's the maximum fucking number. Oh my god. Dude, what the fuck is wrong with me? Yeah, but I was doing so good. I don't even know why it has a decimal place. I think that's gonna fix it. Damn, I'm kind of upset about that one. I'm kind of upset about that one. Why is this in like? You gotta floor it or some shit? Is that what it is? Dude, what the hell? Wrong answer. How do we keep getting these fucking why are we getting like decimal points? Why are we getting decimal points? Like why? Why on God's green earth would we be getting decimal points? I take a piss. This is so stupid. It's not stupid. I'm just like kind of retarded. Making sure an integer. Yeah, whatever. Whatever. That's crazy. I fucked that up badly. I got issues. How long have I been streaming? 3 hours and 44 minutes. Oh, brother. We gotta redo that. We gotta redo that. That's so sad. That is so sad. Actually, I don't think it'll take that long. All right. That shit was low-key sad. All right, everyone, let's get into the code. So the first thing we want to do is make our pointers. So left will be equal to 1, because the minimum she can eat is 1 banana per hour. And our right pointer, which will represent our max, would just be the max of piles, whatever the max integer is in piles. Next, what we want to do is create a variable called res, and that's going to store our possible answers. So since we're returning the minimum, we want the number to be really high at first. All right, so next we're going to create a variable called res, and it's just going to store our answers. We want the number to be pretty high, so we can compare it to whatever possible numbers, and it has to be less than. Hopefully that makes sense. So in this case, you can use anything, float infinity. I like to use IE9, because usually we do not use any number that's greater than that. It's a pretty big number. Or float infinity also works. I need to reset. All right, so next we're going to have a variable called res, and it's just going to hold our possible answers. And we're going to start off at a really high number. So I'm saying 1E9. 1E9, a really big number that's bound to change. Next, what we need to do is create our helper function. As you remember how we did the math.ceiling and we calculated how many hours it would take her to eat all the bananas at a certain rate? As for example, when we looked at an eating rate of 3 bananas per hour, it took 10 hours, but how do we figure that out? That's where this helper function comes in that I mentioned earlier. So we could do that and say, define a function, we're going to call it total time. And it's going to take in an integer. We're just going to say num for now. And what this is going to do is just like an example. We're going to total equals 0, and we're going to accumulate all of the piles of bananas divided by the total time ceiling, because she will not eat any more bananas past her eating rate in the hour. So total plus equals num ceiling of the number divided by, what the fuck, I'm tweaking out. All right, so here we have our function total time, and it's just going to calculate. All right, so next we're going to create a helper function. As you remember before, we were calculating what is the total time to eat all the bananas. So let's say we're looking at the number 3, and it took her 10 hours. But how do we figure that out? Well, what we do is just say, and I'm going to go over this again just so everyone's clear. Let's say we're eating at a rate of 6 bananas per hour in this example. We say 3 divided by 6. And what is that? It's 0.5. But she can't eat half a banana an hour, so we have to round up to the nearest whole number because we're working in 1 hour intervals. So in this case, it would be 1. That would be rounded up, and that would be 1. And that's how we would determine that it would take her 1 hour at an eating rate of 6 bananas an hour to finish 3 bananas. So what we're going to do is have a function called total time. Let's call it that. Makes sense. And it's going to have a variable, one parameter, which is a number, and we're going to turn it an integer. So num is going to start off at 0, and what we're going to do is accumulate all of the numbers, iterate through the piles, and do that same equation. So for pile in piles, not files, piles, total plus equals ceiling of the number or the pile divided by our eating rate or number. And after that, all we have to do is return the total. And there we go. So that returns the total number. And this gives us the total time it takes Coco to eat banana at any number. So we don't have to redo this anywhere else. Next, what we're going to do is go through and make our while loop. So we're going to say while left is less than or equal to R, which is just, as you remember, when our left and right pointers were right next to each other, that just means that we'd stop the for loop. because after this, we'd move the left pointer up and it'd be on the same exact place, and we need to stop because there's no other numbers to check. All right. And what's the first thing we do? As you remember, when we had a left of 1 and a right of 11, we found a midpoint of 6. So we need to find our midway point. So we're going to make a variable called m. And m is just going to be the left plus the right integer division by 2, because we don't want any decimal places. All right. I forgot the equal sign there. All right. Now we need a variable time because we need to check how long does it take Coco to eat all the bananas at m bananas per hour. So we're going to say time equals total time, which is our helper function we just made, and the parameter is going to be m. So that'll tell us the total time. So here's the fun part where we actually move the pointers. So I'm going to go back to the example to help elucidate this. I'm not sure if I could delete these red arrows without deleting everything. Oh wow. That's amazing. Okay. So when we're looking at the number 6, because at the midway point between 1 and 11, we saw that it took Coco 6 hours to eat all of the bananas. So what does that tell us? So that means that if it took her 6 hours to eat all the bananas and we're looking for the minimum number, we don't need to check anything greater than 6. And we already checked 6, so that's where we move our right pointer to m minus 1. So if the time is greater than h, which is the time until the guards come back, we say that the right pointer equals m minus 1. Next, we do the same thing for the opposite. So remember when we were looking at the midway point of 3, and it took her 10 hours to eat all the bananas? That's too big. That's too many hours. So anything less than 3 would take even more hours to eat all the bananas. So we're going to basically invalidate and not have to check anything less than or equal to 3 now. And we're going to move our left pointer up to the 4, or m plus 1. So we're going to say if time is less than or equal to h, the left pointer will equal m plus 1. There we go. And there's one more thing we got to do. Remember our variable res we created up here? If the total time is less than h, that means it's a possible answer. So here is where we're going to check that. So we're going to say res equals the minimum of whatever res was previously and our m, which is our eating rate per hour. Just like we saved all these numbers here, we only want to capture the smallest one we find. So there we go. And once that's done, we should be able to just return res. And remember, we're supposed to return an integer. We just want to make sure it's an integer. So we're going to put int res and double check everything. And let's submit it and see what happens. Hopefully we do well. Yo, dog, I get my ass kicked by this problem. Yo, there's no way I'm this retarded. Did I just fuck this up again? What? If the total time is greater than h. How is this the wrong answer? I'm actually baffled. Output 6. Yo, what the hell? I literally somehow solved this by myself before. I swear I'm writing the same thing. What am I doing wrong? Time equals total time m. I did it backwards. I did it backwards. Dude, that's how tired I am. That's how tired I am. That's how tired I am. If the total time is greater than... I did it backwards. Oh my god. 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 That was so depressing. Alright, let's start from here again. Alright, so here we have our helper function. So now we're going to get into actually moving the pointers around. And it's actually one of the most fun parts, the core principle of binary search. So we're going to say while left is less than or equal to r, in this case, as you remember, when our left and right pointers are equal to each other or crossed, we want to stop because there's no possible numbers we can check. If left is at 4 and right is at 5, there's nothing in between to check, so we should stop. And that just ensures we don't have an infinite loop. And as you remember, the first thing we did was find the midway point, so we're going to call that m. And m is going to equal the left plus the right floored, or integer division by 2. Next, what we want to do is find the time. As you remember, this is just, m represents the eating rate. We need to know how long it takes Coco to eat all the bananas at that eating rate. So time equals total time m. And use our helper function here. So here's where we move the pointers. And I'm going to go back to the example to help elucidate things. So remember in our first example where left is at 1 and right is at 11? So our midpoint would be 6. It took Coco 6 hours to eat all the bananas. So what does that tell us? That means that we were able to eat all the bananas in the allotted time. So do we have to check any numbers that's greater than 6? If we chose something like 7 or 8, it would take... that would be even more hours, and we're looking for the smallest number. So if time is less than h, which means we ate the amount of bananas in the allotted time. Okay, chill. All right, so here's where we move the pointers. So we have the total number of time it took her to eat the bananas. Let's look at go back to an example and help elucidate things. So remember when, in our second iteration, when we had the midway point at 3, it took Coco 10 hours to eat all those bananas. So we saw that anything less than 10 or less than 3 would give us a number greater than 10 to eat the bananas, because at an eating rate of 3, it takes 10 hours. So eating rate of 2 would be even greater, and that's above the allotted time of 8. So if time is greater than h, what we want to do is move our left pointer to equal m plus 1. Just like when we're here, we said that if it took 10 hours to eat an eating rate of 3, we know that everything less than 3 is going to be even more, and those are not valid answers, so we cross those out. And that's why we move our left pointer to m plus 1, and that's how our left pointer got from 1 all the way to 4. All right, so now we're going to check out the inverse. The inverse is if time is less than or equal to h, what do? We go back to our example. Remember the first example when we were looking at when left was at 1 and right was at 11, we saw the midway point was 6. At an eating rate of 6 bananas per hour, it took Coco 6 hours to eat all these bananas. So what does that tell us? It means we can get the job done in 6 hours. So anything greater than 6, we don't have to check because we found something that works that is at 6. If we check 7, that's greater, and we're looking for the least amount of time or the lowest banana eating rate per hour to eat all the bananas. So we don't have to check any of these because 6 is the best possible answer we found so far. So how do we simulate that? That means we move our right pointer to m minus 1. So if the time is less than the allotted time that we have until the guards come back, we say that our right pointer equals m minus 1. And there's also one more thing we need to do. If the time it takes to eat the banana at whatever rate is less than h, which is our allotted time, that means it's a possible answer. So how do we check that? We're going to say res equals the minimum of res and what do? M, because m is our current eating rate per hour. And that's exactly what we did here. We had all these possible answers, and all we want to do is find the minimum. So in this case, it would return 4. And this should be good. We should be able to just return, and we want to make sure it's an integer. Always make sure the types are correct. So we're going to turn res as an integer, and we're going to submit this, and let's see what happens. Oh, there we go. We're able to solve the problem, and it's actually pretty efficient. It beats 97% at runtime. So hopefully this makes sense, and if you have any questions, just drop them down below. Oh my god, kill me. Oh my god. Oh my god. Oh my god. That was actually AIDS. That was actually like that actually was terrible. That actually, like, legitimately was terrible. Oh my god. Binary search kicked my ass today. I got my butt handed to me by binary search. Like, kill me now. This video is an hour long. Am I retarded? Yes. Alright, hello everyone. Today we're going to be solving LeetCode 875, Coco eating bananas. A very fun one. Coco loves to eat bananas. Okay. Okay. I'm so done here. Kill me. That means she would finish this pile. Has piles I bananas. The guards are gone and will come back in H hours. Coco. Alright, so I stop explaining like right here. Within H hours. Alright, so we're going to quickly go over the example and explain why this is the right answer. So, the output is 4. And let's see. Let's say she eats at a rate of 4 bananas per hour. That means she would finish this pile. Oh, sorry. She would finish the first pile in 1 hour. Because remember in the directions, it says that if the pile has less than k bananas, she eats all of them instead and will not eat any more during this hour. God damn. Yo, this problem kicked my ass. Oh, sorry. She would finish. Like, holy moly. This problem kicked my ass. And like, she would finish badly. Oh, sorry. She would finish the first pile in 1 hour. Because remember in the directions, it says that because remember in the directions it says that. Dude, that is so terrible. At least we could just edit now, you know. The first pile in 1 hour, because remember in the directions it says that. Because remember in the directions it says. Oh. Remember in the directions it says that if remember in the directions it says that in the directions it says. Yo, I'm about to die. The directions it says that if the pile has less than K bananas, she eats all of them instead and will not eat any more during this hour. I think did I explain the whole problem in the other section? Because holy fuck, I'm retarded. Yo, it took me like 3 whole times. I fucked it up here. Yo. That's so sad. That shit was depressing, my nigga. Goddamn. Wait, hold up. That is so sad. Actually, I don't think it'll take that long. All right. I think I clap so I could like know when to cut. All right, so this whole clip here, this is 17 minutes long. God damn. What am I doing for 17 minutes? I just like, all right, let's like, what am I doing for 17 minutes? Being retarded? That shit was low-key sad. It was. All right, everyone, let's get into the code. I have to just act like that did not happen. It took me an hour to solve this problem. That's like. All right, everyone, let's get. It took me longer on camera than it did off camera. What do is make like what? So left will be equal to 1 because the minimum she can eat is 1 banana per hour, and our right pointer, which will represent our max, would just be the max of piles, whatever the max integer is in piles. Next, what we want to do is create a variable called res, and that's going to store our possible answers. So since we're returning the minimum, we want the number. Oh, no. This is what I fucked up here. I started like yapping so heavy. I started yapping so heavy here. Like I made res, started talking, and then I deleted res, and then like. Yeah, I made res here, and then I even deleted it, I think. Yeah, let's just delete that. Here's the piles. All right, so next we're going to create a variable called res, and it's just going to store our answers. We want the number to be pretty high, so we can compare it to whatever possible numbers, and it has to be less than. Hopefully. God damn, I'm retarded. Dude, that was like the most unclear explanation of that. Like you couldn't pay me to make a more unclear explanation. I need to reset. All right, so next we're gonna. Yeah, I had to just like chillax. I had to just relax, bro. Let's just relax. All right, so next we're gonna have a variable called res, and it's just gonna hold our possible answers, and we're gonna start off at a really high number. So I'm saying 1e9, 1e9, a really big number that's bound to change. Next, what we need to do is create our helper function. As you remember how we did the math.ceiling and we calculated. Dude, I don't even know if I have a math.ceiling. I think I fucked this up. Actually, I didn't mess this up. I didn't. I don't remember. I have to do this in like sequentially. But this is the solve. All these other ones, while I'm like coding stuff, like it's just not the answer. Like if I'm coding, that's I guess this is not the answer. When did I start coding the first time? Now, here. Let's make this a bit bigger so everyone can see. Yeah, it's there. Just delete this whole entire thing. This is just sadness, depression. All right. We're down to 32 minutes. We've shaved off a whole half an hour. That's great. That's great. Okay. Did I explain this well? 30 minutes is way too long. I think I had 2 explanations. Like, one of them is like... I had like 2 explanations. Wait, no. I don't think I was supposed to cut that off. Here. This is good. This is good. Cut all that off. I think I explained the whole problem here. I had to get the hang of it. That was like a good practice one. I don't like how that came out. Yeah. All right, so let's look at this. Okay. I think this is the... All right, so let's look at this example here. What I like to do first is let's look at the bounds. What are our possible answers? So let's look at something like our min. What? Okay, that's the proper explanation. Explaining the problem. 2 hours because in the first hour we need to get 4 bananas, but she won't eat. So it takes her exactly 1 hour to eat 3. Okay. We should definitely instead, and will not eat any more during this hour. So it takes her exactly 1 hour to eat 3 bananas because she has an eating rate of 4 per hour. How many hours will it take her to eat 6 bananas? It would be 2 hours because in the first hour she eats 4 bananas, but she won't eat any more in that hour. And the remaining hour, there'll be 2 bananas left, and she'll eat those and not eat any more in that hour. Hopefully that makes sense. Next, we see that for 7 bananas, she would eat 4 in the first hour, then 3 in the next hour, so that would be 2 hours in total. And for 11 bananas, what do we think it is? It would be 3 hours because she eats 4 bananas the first hour, 4 bananas the second hour, and 3 bananas the third hour, and that gives us 11. And all of these summed up would be, this would be 2 plus 2 is 4, 5 plus 3 is 8. That means it took Coco exactly 8 hours to eat all of these bananas. But let's see what happens if we gave her a banana eating rate of, let's say, 3 hours. Because we know this is the answer, but let's pretend we didn't know. So if she had a banana eating rate of 3 hours, it would take her 1 hour to eat the first pile, 2 hours to eat the second pile. Here, it would actually take her 3 hours to eat 7 bananas because the first hour she eats 3, the second hour she eats 3, but that would leave 1 more banana left, and she can't eat any more within that hour, so she'd have to stay for a whole additional hour just to eat 1 banana. So that leaves us at 3 hours to eat 7 bananas. And once we get up to 11, she'll eat 3 bananas the first hour, she'll be up at 6 bananas in the second hour, 9 bananas in the third hour, and 12 bananas on the fourth hour, but there's only 2 bananas left. So it would take her 4 hours to eat 11 bananas. And we sum all of this up, and what do we get? 10. We get 10 hours. So with an eating rate of 3 bananas per hour, it would take Coco 10 hours to eat all of the bananas in the pile. But the guards are back in 8 hours. So she doesn't have enough time. So that's why the answer is 4, because 3 takes too long, but 4 is in the constraints of 8 hours. Alrighty. I explained all that in 3. That's beautiful. All right, hopefully that makes sense, and I hope elucidate like at least the probable statement. So let's get into how we actually solve it. Okay. I didn't like how I like did this. I think like low-key that could be deleted. So we have like, okay, now we explain that. Now we need. All right, so let's look at this example here. What I like to do first is let's look at the bounds. What are our possible answers? This is a 23-minute clip. Let's look at something like our min. Why the fuck did it take me 23 minutes to explain this? Number of bananas Coco can eat. I sound glitchy again. 1 banana per hour. I sound glitchy again. My mic sounds glitchy. Again. I'm so happy it didn't glitch out in the video. I'd cry. Wait, so what's wrong with my mic? Like, hello, hello, hello. It's glitchy? It's glitchy right now. I'm glitching? Am I glitching? I want to go run, bro. I want to go run. I'm done with this. Get me out of here. Am I glitching? No, it's not you. I think it's probably. Wait, I'm still glitching? Dang. I don't know what's going on there. You can text me on my phone. I'm still glitching. I'm not sure why. I'm not sure why it does that. Hello, hello. Yeah, it sounds weird. Why is it glitching? I don't know. All right, hello. Is it still glitching? Hello, hello. It's not glitching anymore, right? Yeah, I think I fixed it. I don't know. Yeah, I'm not sure what was going on there. I'm getting my ass handed to me by this fucking problem. I'm retarded, bro. But here's a bit of a tricky. Nah, sorry. I shouldn't say that. That she can eat. It would be whatever is the maximum number in the piles. In this case, it would be 11. As we can see, 11 here. So the maximum number that Coco can eat is 11 bananas per hour, because she would be able to finish them in 4 hours, because that's the length of the array. I take one eating rate of 11. She can eat every single pile in only 1 hour. All right, and so now the question is, how do we find what is the most efficient way to eat the bananas in H hours? Yo, I'm so fucking. I'm too glitching. All right, we need to. I don't know how I could possibly make this video 5 minutes, bro. So now the question is, how do we find this is insane. The most efficient way to eat the bananas in H hours from our range? We see that the min is 1 and the max is 11. So let's quick. In H hours from our range, we see that the min is 1 and the max is 11. So let's quickly draw that out here. I might skip ahead. 1, 2, 3, 4, 5. Bananas in H hours from our range. We see that the min is 1 and the max is 11. So let's quickly draw that out here. Oh my god. Oh my god. Just speed it up, like. Quickly draw that out here. Make it even faster. Who cares? So let's quickly draw that out here. Okay, so we have our number line here, and these are all the possible answers. And our left pointer should be at the minimum possible answer, and our right pointer should be at the maximum possible answer. Somebody slay me. Why is this video still 43 minutes? What did I do for 40 minutes? Oh, I think I was just getting the wrong answer a bunch of times. It had to be this. Yeah, this is me like fucking up a bunch of times. Yeah, it's just me just like getting the wrong answer. We're at 27 minutes still? What the hell were we doing? What are we doing? 27 minutes? Are you like... How do you even do this problem justice in 5 minutes? Like, what? Minimum possible answer, and our right pointer should be at the maximum possible answer. So, as you guys remember in binary search, what do? We find the midway point. So, we do the left plus the right divided by... Yo, I can't do this shit no more. Nah, that Coco... Right divided by 2. Because you go smack dab in the middle, because we don't know what number it is, so we always try the midway point. Safest option. 11. Alright, there has to be like big points in this video that I could like cut up. I want to make this video like 12 minutes. So what's 11 plus 1? 11 plus 1 is 12. I'm over here like... Please, someone off me, man. Right. 2 is 6. So that gives us a midway point of 6. So we have a mid of 6. How am I supposed to do this? How? Waypoint of 6. This is insane. Of 6. Now, what do we have to do next? M is going to represent a possible answer, which is going to be the number, the eating rate that Coco is going to... God damn, what am I a possible answer? I feel so fresh now, bro. Like, I'm fucked up, man. Now, what do we have to do next? M is going to represent... It is a possible answer, honestly. But, like, I say it such, like, unconfidence, you know what I'm saying? I say it like, I don't know. Represent a possible answer, which is going to be the number, the eating rate that Coco is going to be eating all the bananas. God damn, what? What did I just say? M is going to represent a possible answer, which is going to answer. Like, yo. Possible answer, which is going to be represent a possible answer, which is going to be the number, the eating rate that Coco is going to be eating all the bananas. But we have the eating rate, but we have to know what is the total amount of time that it takes her to eat all the piles of bananas at this eating rate, in this case 6. So what do? We'll have to iterate over the piles. Okay, this is getting good. Not sure how we're at 27 minutes still. There's no way in hell it took me 27 minutes to explain the rest of this. And we'll have to iterate over the piles. I must have fucked up a lot of times. And what we're going to do is use our eating rate and divide it by the pile and sealing it. And I'm going to explain why we have to do the sealing. So let's say we had 3 divided by 6. That would be 0.5. She can't eat banana in 30 minutes because we only work in hour intervals. So we sealing it up, and that would be 1. And as you see, just like in the regular example, it takes her 1 hour to eat 3 bananas because we always have to sealing up because she has to wait until the end of the hour to go to the next pile or stay on the same pile and eat the remaining bananas. So we're going to have a helper function that's going to do that for us. So we see 6, and we're going to calculate how many hours it takes Coco to eat all the bananas at an eating rate of 6. Let's quickly do that. So let's say we use our function, we ceiling it up. This would be 1, 1, 2, 2. So that would be 6. So that means it would take Coco 6 hours to eat.
Did I explain that one?
Until the end of the hour to go to the next pile, or stay on the same pile and eat the remaining bananas. So we're going to have a helper function that's going to do that for us. So we see 6, and we're going to calculate. We only work in hour intervals, so we ceiling it up, and that would be 1. And as you see, just like in the regular example, it takes her 1 hour to eat 3 bananas, because we always have to ceiling up because she has to wait until the end of the hour to go to the next pile, or stay on the same pile and eat the remaining bananas. So we're going to have a helper function that's going to do that for us. So we see 6, and we're going to calculate how many hours it takes Coco to eat all the bananas at an eating rate of 6. Let's quickly do that. So let's say we use our function, we ceiling it up. This would be 1, 1, 2, 2. So that would be 6. So that means it would take Coco 6 hours to eat. One, 1, 2, 2. So that would be 6. So that means it would take Coco 6 hours to eat. Let's write this here. It would take Coco 6 hours to eat all the piles of bananas. How many hours it takes Coco to eat all the bananas at an eating rate of 6? Let's quick. So that means it would take Coco 6 hours to eat.
I think I just said it again over here.
Let's write this here. It would take Coco 6 hours to.
Yeah, I just like delete this shit.
Up would be 1, 1, 2, 2. Let's write this here. It would take Coco 6 hours to eat all the piles of bananas at an eating rate of 6, because that's where our midway point is. All right, and what does that tell us? 6 hours is less than the allotted time 8, but this is a possible answer, so we're going to save it. But where should we move our pointers? We know that 6 can get the job done, so should we check anything greater than 6? I'd
No.
say no, because if 6 can get the job done, why would you want to eat at a higher number if we're looking for the lowest number possible? So what we can do is actually cross out all of these numbers. We don't even have to check them.
My guy, this is insane. This is insane. Like, I'm doing way too much work right now.
And we already checked 6, so
Why is
our
this
new
video 27
right
minutes?
pointer should be m minus 1, because we haven't checked 5. So now our right pointer should be.
I think this, I must have like tweaked out somewhere. I'm going running after this. And I got work tomorrow.
Be at.
Oh my god, I have another break. My long break, 30 minutes. Should I just come back later? I guess I probably should.
And we've essentially crossed out half of our array already.
I might go running.
Crossed out half of our array already. And we're going to follow the same algorithm here. So our right.
I'm retarded. Let's do that stand-up shit, okay. I never knew how long this would take. Man, oh man, if I knew how long this would take. Man, oh man. Man, oh man. If I knew how long this shit would take, I'd quit. I'd quit. I'd fucking quit. If I knew how long this would take, I would quit. Okay. Uh, 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 like, okay. Wait, Bree get a job? Holy fuck, holy fuck, holy fuck, holy fuck. I don't know. Dude, piece of shit. I hate that video, bro. What the Ecuadorian flag? Ah. Yeah. Okay. Okay. I have to finish editing this video, but I think I have to turn off stream. It's in 5 hours. I can't do this no more.